For part A, the Hooke's law is Fs equals negative kx. And since k is constant and f is here, so f equals to y. So I'm just going to replace that equals to y equals negative x. And if you plug in a negative number, y would be positive. So I'm just going to put it right here. And as it's approaching positive, it's going to go down in the y direction. So for part B, on the xt graph, it will start at negative a, which is here, and it's gonna go to peak and go back down, and it's gonna be a cosine graph. For part B, for the velocity t graph, it's going to start at 0, and it's going to go up to the positive direction, and it's going to be a sine graph. So it's going to hit 0 here, go down here, and go back to 0. And it's the same thing for the second t. For part B, for the acceleration t graph, I'm going to start in the positive direction and ends in the positive direction because it mirrors the position t graph. And so I'm just going to do cosine graph, but positive. For part C, I agree because the equation for Vmax is negative omega A. So if A goes to 2A, then the V will double. Because there's an A in the equation, in the Vmax equation. For part D, I disagree because A does not affect the equation of F frequency. And the equation is sorry. For part E, I'm gonna start with MEI equals to MEF. And for MEI, there's a springs at first, so there's gonna be PES. And there's no velocity, so there's no KE. And for the other side, it's gonna be PES plus KE linear. And for PES, it's going to be 1/2 KA squared equals to 1/2 KX squared plus KE is 1/2 MVF squared. And all the terms have 1/2, so I'm just going to cancel that out. And I'm also going to move the kx squared over. So I'm going to do that by subtracting it over. MVF squared. And I'm going to take out the k. And that leaves this equals to MVF squared. And I'm going to move the m over. So I'm going to divide. And then I'm going to square root both sides. And radical k over m equals to omega, and it's plus or minus because it's radical. And I'm just going to leave the a squared minus x squared in the radical. For part F, I'm going to draw the force Fn and Fg for both because they're the same. And for Fk, I'm going to draw it pointing left because it's moving right. And for Fs, for toward the equilibrium, it's going to point right. And for away from the equilibrium, it's past the equilibrium, so it's going to point left. For part G, I'm going to start by drawing the ticks on the y-axis. And for scenario 1, it starts at negative a, and it will go up to positive a and go back down, and that's one period. And it repeats, and it'll end at negative a. But for scenario 2, it starts at negative 2a, and it'll go all the way up to positive 2a and back down to negative 2a, and same thing for the second period. For part I, A3m is less than am. Because the collision is inelastic. Because it's stuck together. So the mechanical energy is not conserved. And this caused the total energy to be lower, higher mass, and higher V due to the momentum being at equilibrium. So ME is 1/2 KA squared. So the A depends on the square root. So energy decreases after the collision. So the A3M will be less than AM.